Hello space enthusiasts, and welcome back to the channel. Today, we're taking a deep dive into the churning, chaotic, and utterly beautiful atmosphere of the king of planets, Jupiter. For centuries, we've stared at its iconic stripes, those bands of clouds and powerful winds we call jet streams, racing east and west across the planet. We thought we had a pretty good handle on them. But as it turns out, we were only scratching the surface. What we saw was just the tip of a colossal atmospheric iceberg. The game changer, as it so often is in modern planetary science, was NASA's Juno mission. Juno wasn't designed just to take pretty pictures. Its primary mission is to peer beneath the clouds to understand what makes Jupiter tick from the inside out. Using incredibly sensitive instruments to measure Jupiter's gravitational field with unprecedented precision, Juno uncovered something that has rewritten our understanding of gas giants. It found that the familiar jet streams we see at the cloud tops aren't just a thin, superficial layer. They are the visible manifestation of something much, much deeper. Imagine the most powerful hurricane on Earth. Now, imagine it being thousands of kilometers deep. That's the scale we're talking about. Juno's data revealed that these jet streams extend downwards, possibly as far as 3,000 kilometers, or nearly 2,000 miles, into the planet's interior. This is staggering. It means these atmospheric patterns are not just weather. They are deep-seated structures that contain a huge amount of Jupiter's atmospheric mass. To put that in perspective, Earth's entire atmosphere is only about 100 kilometers thick. Jupiter's jet streams are 30 times deeper than our whole atmosphere. These aren't gentle breezes either. The winds within these jet streams can reach speeds of over 360 kilometers per hour, or about 225 miles per hour. And they are organized into a system of nested cylinders, all rotating at different speeds around the planet's core. Picture a set of Russian nesting dolls, but instead of solid dolls, they're made of swirling, super-fast gas, all spinning around a common axis. The deeper you go, the more bizarre it gets. The sheer scale and power of these deep jets were completely unexpected. They forced scientists to ask a brand new set of questions. What is driving these colossal structures, and just how deep do they go? This is where the story gets even more fascinating and mysterious. While the jet streams go incredibly deep, they don't seem to go on forever. At that 3,000-kilometer depth, something changes. The uniform rotation seems to break down, suggesting the jet streams are hitting some kind of boundary layer. What could possibly be powerful enough to stop weather systems that are thousands of kilometers deep? The prime suspect is one of the most exotic substances in the solar system, metallic hydrogen. Deep inside Jupiter, the pressure is so immense millions of times greater than the atmospheric pressure on Earth that it crushes hydrogen gas into a liquid metal. In this state, hydrogen doesn't behave like a gas anymore. It acts like a conductor, like molten copper. This layer of liquid metallic hydrogen is what generates Jupiter's incredibly powerful magnetic field, the strongest of any planet in our solar system. The interaction between this conductive, magnetic layer and the atmospheric jet streams above it could be the key. Think about it like this. The moving jet streams drag Jupiter's magnetic field lines. This dragging action, according to the laws of physics, creates a force, a kind of magnetic friction that opposes the motion of the winds. It's a phenomenon known as magnetic drag. This force would get stronger the deeper you go. As you get closer to the main source of the magnetic field, it's a battle between atmospheric motion and electromagnetic forces on a planetary scale. So, Juno's discovery isn't just about the weather. It's about the fundamental connection between a planet's atmosphere and its deep interior. The jet streams we see are directly linked to the exotic, metallic heart of Jupiter. This has huge implications for how we think planets are built and how they operate. We used to study the atmosphere and the interior as separate domains, but now we see they are part of one dynamic, interconnected system. Understanding this link could help us understand the atmospheres of other gas giants, both in our solar system, like Saturn, and the thousands of exoplanets we're discovering around other stars. The questions are now more profound than ever. How exactly does this magnetic braking mechanism work? What does the transition zone between the regular atmosphere and the metallic hydrogen layer actually look like? Are there similar deep jet systems on Saturn, Uranus, and Neptune? Juno is continuing its mission, flying closer and closer to Jupiter with each orbit, gathering more data that will help us piece together this incredible puzzle. Every new piece of information brings us one step closer to understanding the true nature of these hidden, colossal rivers of wind that sculpt the face of Jupiter from the inside out. The King of Planets still has so many secrets to reveal. Thanks so much for joining me on this journey deep into Jupiter's atmosphere. It's a reminder that even for the planets we think we know well, there are always incredible new discoveries waiting just beneath the surface. If you found this as mind-blowing as I did, please hit that like button. And be sure to subscribe and turn on notifications so you don't miss our next deep dive into the cosmos. Stay curious, and I'll see you in the next video.